I'm Dr. E. I'm really sad that I won't get the chance to actually meet everyone, but we can still have fun with this now that we have to have virtual classes. Now the way it's going to work, sometimes I'm going to videotape myself with a whiteboard behind me, and other times I'm just going to use a whiteboard on an iPad and then send it to you guys. We can still have fun with this and make it interactive. So, ready to get started? Okay. Now, many of you guys, this is the first chemistry class you've taken. Here's what I want you to do. I know I can't see you, but I still want you to do this. Raise your hand if you have done any of the following in the past 24 hours. Drove a car, used lotion, took Advil or aspirin, used a plastic bottle, listened to a CD. Sorry, this list is pretty old. Hey, if you still have a CD, no judgment there. Dyed your hair, made breakfast, used soap. Hopefully everyone has their hands up right now. So if you did any of these fun, even if the ones that I mentioned in the last 24 hours, you've done chemistry without even thinking about it. Chemistry is all around us. A lot of things that you do on a daily basis are chemistry. You just don't think about it. So what I'm hoping is by the end of this quarter, you're going to have an appreciation for all this chemistry reaction that you do on a daily basis. Now, the first thing we need to talk about in Chem 38, we need to talk about measurements. And the reason for that is scientists, they measure things all the time. And when they measure things, there are two things that we have to be careful about: units and significant figures. I'm going to talk about those two things today because scientists measure things all the time. Now, before I talk about those two things today, there is one more thing that I want to make sure you remember from your high school years. And that is scientific notation. Scientific notation. What's a scientific notation? Now, scientific notation is basically when you have too many zeros, we want to make the number to look nicer. Don't write that down. Let me give you an example to show you what I mean by that. Okay. I'm going to draw something on the board. And the other thing you're going to find out that my drawings are not the best. So you have to use your imagination a little bit. So what is this? This is the sun. Okay? This is the sun. Now the sun has a diameter. The diameter of the sun is 139200000 meters. That's the size for the diameter of the sun. Look at that number. How would you even say that number? That's it's a mouthful, right? So you want to make it to look a little bit nicer. That's where the scientific notation comes into play. What am I going to do? I'm going to move it until I get to the first number. So I go 1, 2, 3, 4, 5, 6, 7, 8, 9. So 1.392 times 10 to the 9th. That's a little bit nicer number, huh? Now, I'm going to draw an atom. Let's just say this is an atom. An atom also has a diameter. The diameter of an atom is 0.000000003 meters. Mouthful, huh? Way too many zeros. Doesn't look good. Let's make it look a little bit nicer. So, again, I'm going to keep moving the decimal, in this case, until I get to a number. It's not 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's 3 times 10 to the negative 10. Now, why is this one negative 10 and that one was positive 9? Now, think about it. this number is a huge number, right? If it's a huge number, it's got to be to a positive power because it's a big number. Versus this one, this is a very, very tiny number. So that's why I'm going to have to the power of -10. Now, the memorizing here, which again, I want you to understand it, is when you are moving to get to a number, when you move this way, is 10 to a positive number. When you move to the right, is 10 to the negative number. So we move this way here, it was a negative. We move to the left, it was a positive number. Okay? So it's a kind of a little memorizing way, but I really want you to understand that this was a positive number because it's a huge number. This is a tiny number, so it was to the -10. All right, so now that you hopefully remember scientific notation, let's do a few practice problems. You ready? Okay, let's do a few practice problems. What I'm gonna do, I'm gonna write down a few numbers and I'm gonna ask you to write them in scientific notation. And remember, you can pause me anytime you like. You can even mute me anytime you want. So I want to put these numbers down. I want you to pause me and I want you to write this in scientific notation and then unpause me again and we're going to go over them together. So here are the numbers. 2, 3, 4, 0, 0, 0, 0.00919, 0.0124, 19500. What do I want you to do? I want you to express them in scientific notation. Okay, let's go over them together. The first one, okay, I'm gonna go 1, 2, 3, 4, 5. 2.34 times 10 to the 5th. Okay. All right. Next one. I'm going to go 1, 2, 3. So 9.19 times 10 to the -3. Again, remember what we said. We said when we go this way is negative and we go to the left is positive. But again, this is a small number. That's why it's negative. Think about that too. Now, how about this one right here? I go 1, 2, so 1.24 times 10 to the -2. Now, the last one, 1, 2, 3, 4. So I go 1.95 times 10 to the 4th. So far, so good. Okay. Now, some of you guys might say, hold on, I had a slightly different answer. Could you do this? Could you go 1, 2, 3, for example? So that is 19.5 times 10 to the 3rd. Sure, you can completely do that. That would be the same thing. Now, what I like to go all the way to the first number just to be consistent. But if you want to do it this way, that's also okay. That's also scientific notation. For example, here, I want to say, can I do 1, 2, 3? Sure. 12.4 times 10 to the -3rd. That's okay too. That's okay too. You just keep track of how many places you go for your scientific notation. All right. So hopefully that was a good review of scientific notation. So we're going to use this as we do practice problem. Every time you see a lot of zeros, do a scientific notation so it's nicer looking. It's easier to read it. It's not a mouthful. So we said scientists do measurement on a daily basis. You measure things on a daily basis, right? You measure things on a daily basis. Now, when you measure something, you get a number. A number means nothing without a unit. I weigh 100. Well, 100 what? Pounds, kilograms, grams, ounces? That makes a difference, doesn't it? So every time you measure something and you get a number, if that number has no unit, that number doesn't mean anything. So you always have to have a unit next to a number. Remember that. Now, what do you measure on a daily basis? Tell me some of the stuff that you measure. There are 5 things that we measure on a daily basis. We measure And again, shout it out to me, even though I can't hear you. We measure length. We measure mass. We measure volume on a daily basis. What else we measure? We measure temperature. And we measure time. These are the 5 things we measure on a daily basis. And every time you measure something, you get a number. And a number means nothing without a unit. And we are going to go over the unit conversion later, difference between the US unit and then the metric system. Now, so you measure something, you get a number, you put a unit next to it. There is one more thing you have to care about, and that is significant figures. Significant figures. So you measure something, you get a number, you put a unit next to it, you're not done yet. Then you have to care about significant figures. Now, we are going to go now over the significant figures and what's significant figures. Now, raise your hand if you've done significant figures. Now, raise your hand if you disliked it, which is probably all you guys. Significant figures is one of those things that it keeps coming back over and over again, and people don't particularly love it. But I want to make sure you understand why we spend so much time going over significant figures. So significant figures is our next thing. Now, do you want to be cool? If you want to be cool, cool chemists call it Sig Fig. You can definitely try to be cool. So cool chemists, they call it Sig Fig. All right, now before I show you how to do significant figures, I want to convince you why significant figures matter. So here's how I'm going to convince you. I got 20 ml, number with a unit, H2O. What is H2O? H2O is water. Good job. I got 20.0 ml H2O. I got 20.00 ml H2O. Okay. I got 20 ml water. Did I spend a lot of time measuring my water to be exactly 20 ml? No. I got 20 ml of water. That means I got around 20 ml of water. I got 20.0. I spent a little more time to make sure my water is exactly 20 ml, 20.0 ml. 20.00. Now I really care about my water. I spend a lot of time to make sure that water is exactly 20.00 ml. Now, I want to teach you in a minute, so if you don't know this, it's okay. 20 ml has 1 Sig Fig. 20.0 ml has 3 Sig Fig. 20.00 ml has 4 Sig Fig. Now, what am I telling you by using different number of significant figures? I'm telling you how accurately I measure something, and that matters. A lot of you guys are going to go into medical field. That matters, right? Showing someone how accurately you measure something. So that does matter. So why do we have to care about Sig Fig? You have to care about Sig Fig because Sig Fig will show you, will show people how accurately you measure something, how precisely you did your measurement. That's what it's going to show me, and that matters. Yeah? Okay. So hopefully you are convinced that Sig Fig matter, because Sig Fig is going to show people how accurately, how precisely you did your measurement, and that really matters. Okay. Now, are you ready for the rules of significant figure? What I'm going to do, I want to give you all the rules, and then I'm going to go over each one and give you example, and then show you how you would do it. Ready? Okay. Let's do it. Rule number 1. Rule number 1. All non-zero digits are significant. I'm just going to put sig for significant. All non-zero digits are significant. Rule number 2, interior zeros are significant. Again, we will go over these rules. Number 3, trailing zeros. Trailing zeros after a decimal point are significant. So trailing zeros after a decimal point are significant. Number 4, leading zeros. Leading zeros are not significant. Okay, we're almost there. Last one. Zeros at the end of a number without a decimal point. Without a decimal point are not significant. Okay, you have all the rules. Now, let's go over one by one. What do I mean for each one? Let's go over one by one. What do I mean for each one? You ready? Okay, let's do this. So the first one, all non-zero digits are significant. So let me give you an example. Here, an example. 1.5. 1.5. How many sig fig does 1.5 has? 2 sig fig. Good job. It has 2 sig fig. Okay. Again, all non-zero digits are significant. Interior zeros are significant. So if a zero is sandwiched between numbers, that zero is significant. Here's an example. 1.05. How many sig fig is that? 1.05. That is 3 sig fig. 1.05. That's 3 sig fig. So if a zero is sandwiched between numbers, that's significant. Good job so far. Trailing zeros after a decimal point are significant. Okay. Here's an example. 1.050. Take a minute. If you have someone around you right now, tell someone around you. 1.050. How many sig fig is that? What do you think? That is 4 sig fig. 1.050 is 4 sig fig. 1, 2, 3, 4. Now, we knew that zero count because it was sandwiched between the numbers. How come this zero count? Remember, what I could have said, 1.05, okay? 1.05 versus 1.050. These two have the same value. 1.05, 1.050, they have exactly the same value. So if they have the same value, why am I going further and telling you that is 1.050? Why am I putting the extra zero over there? Because I'm showing you that I spend more time and I spend more time to measure that, and I measured it more precise. Okay? So that's why this is 4 sig fig, this is 3 sig fig, this 0 is significant because I'm telling you that I spend more time measuring that. I could have just said 1.05 and it's the same value, but I said 1.050, telling you that was more accurate measurement. Okay, beautiful, nice job. So in the decimal place, the zeros after the number matters. Leading zeros are not significant, okay? So here's an example for leading zeros. 0.001050. We're getting pretty fancy right now, right? 0.001050. Okay. Now, we knew that these four are significant, right? 1050, because sandwich between number, if you have a zero after a number, then you have a decimal, it counts. So we knew that. Now, are these significant? Those are not insignificant. Here's why. Because the only reason we have those is because they're showing us this is a tiny number. That's all it is. They're just showing us that this is a tiny number. So it's not significant because it doesn't have any significance in it. I didn't spend more time measuring it. I'm just telling you that I had to put those zeros to show you that this is a small, tiny number. But these four, they do matter, right? So this is 4 Sig Fig. These don't matter, leading zeros doesn't matter again, because the only reason I put these here just to show you that this is a small number, not to show you that I spend more time measuring it. Okay, so far so good. Guess it, these not significant. Zeros at the end of a number without a decimal are not significant. So here is an example. 150000. How many Sig Fig is that? That's only 2 Sig Fig. If there is no decimal place, the zeros after a number are not significant. Because, okay, I didn't spend that much time. I measured around 150,000, but not accurately. That's around that number. So, if you have zeros after a number, if there is no decimal place, these zeros are not significant. If there was a decimal place, then yes, they would be significant. So this is 2 Sig Fig. Now, do you agree there's too many zeros? Yeah, what do we do when there's too many zeros? Scientific notation. Let's do it. 1, 2, 3, 4, 5. So 1.5 times 10 to the 5th. Now this is a nicer number. Okay, beautiful, beautiful. Now, do you want to do some practice problem? Let's do it. So now that you know the rules of significant figures, let's do some practice problem. Now, I'm going to write down a bunch of numbers and then pause me. I won't take it personal. And what I want you to do, I want you to write down how many Sig Fig does each number have? How many Sig Fig does each number have? Okay, here the number. 0.0040, 1.068, 1020, 1034, 500, 120.0500. Okay, let's do it. You got this. You completely got this. The first one, 0.0040. How many Sig Fig is this? These numbers are not significant. They're just telling me that this is a small number. If you have a bunch of zeros before a number, that's not going to count. It's just going to tell me this is a tiny number. So how many Sig Fig is this? This is 2 Sig Fig. This is 2 Sig Fig. And again, why does this zero count? Because I could have said 0.004 and these two would have exactly the same value, but I didn't say 0.004. I said 0.0040. Okay? So I didn't say that. I actually took the extra time to make sure I say that. So far, so good? Okay. Now, 1.068. How many Sig Fig is that? What do you think? That would be 4 Sig Fig. That would be 4 Sig Fig. Nice job. The zero sandwiched between a number, that counts. 1020. That is 3 Sig Fig. Okay? That is 3 Sig Fig. The zero doesn't count if I don't have a decimal place. The zero doesn't count if I don't have a decimal place. Okay? The zero is not going to count if I don't have a decimal place, because I didn't measure that accurately. Otherwise, I would put a decimal place and let you know. Beautiful so far. Okay, how about over here? What do you think? 10434. That would be 4 Sig Fig. Beautiful. 1034, get a 0 between a number that counts. 500 would be 1. Again, I measured around 500, not that accurately. 120.0500. What do you think? 1, 2, 3, 4, 5, 6, 7. Yes, all these zeros count. Again, if I have a 0 after a number, if there's a decimal place, that 0 does count because I went the extra mile to measure them accurately. So far, so good? Okay, beautiful. Now, there is one more thing I want to mention about Sig Fig before we move on. And again, don't worry, every problem we do from now on, we have to think about Sig Fig, so we keep practicing this Sig Fig over and over again. Now, you're in a science class, you're going to do labs. When you go to labs to do experiment, you measure things all the time in lab. When you measure things in lab, how would you know to how many Sig Fig to report a number? So let's say you're going to go to lab tomorrow and you're going to measure 20 ml of hydrochloric acid. How are you going to report that? Are you going to write down 20 ml hydrochloric acid? Are you going to write down 20.0 ml hydrochloric acid? Are you going to write down 20.00 ml hydrochloric acid? How would you report that? Now, that will depend on what glassware you use in lab. That would depend on what glassware you use in lab. Let's say you go and you use a beaker to do this. To give you an idea, if you break a beaker in lab, that's going to cost you $5, maybe $10. So beakers are not accurate. So if I use a beaker to measure 20 ml hydrochloric acid, I can just say 20 ml. I can't put any decimal places because beaker is not accurate. Now, if I go and get a graduated cylinder, now if you break a graduated cylinder, that's going to cost me $50. That's a little bit more accurate. Then I can say, okay, I got 20.0 ml. So in lab, when you measure things, how accurately you report it depends on what glassware you use in lab. So think about that every time you do lab. So far, so good? Okay, beautiful. You guys are doing a great job. Let's go to the next phase for Sig Fig. Now what I'm going to do, I'm going to do Sig Fig in calculations. Sig Fig in calculations. Okay. Now, Sig Fig in calculations. How am I going to do that? Now, when you do calculations, here's the rule. When you have multiplication or division, here's how you would do. You would go with the lowest number of significant figures. Okay, so when you have multiplication or division, you go with the lowest number of significant figures. Now, here's the way I look at it. Remember that you are as good as your weakest link. Think about that. You are as good as your weakest link. If you're on a soccer team, your team is as good as your weakest player. This is the same thing. You are as good as the number with the lowest number of significant figures. So let's do that together right now. Here's a practice problem. Take out your calculator. I don't mean your phone's actual calculator. Take out an actual calculator and put this in. 5.02 times 89.665 times 0.10. Okay? If you put this number in your calculator, what your calculator is going to give you is 45.01183. A lot of time when you put numbers in your calculator gives you a lot of digits after a decimal place. Have you ever thought about, where do I stop? Do I write down all these numbers after a decimal place? Have you ever thought about that? Yeah? Are you thinking about it now? Yeah. Sometimes you put a number and the calculator gives you a lot of digits after a decimal place. And the question is, where do I stop? How many numbers do I report? Well, that depends on the significant figure. Okay, let's do this together. You ready? You got this. Let's do it together. 5.02. How many sig fig is that? 3 sig fig. Beautiful. 89.665. How many sig fig is that? 5 sig fig. 0.10. How many sig fig is that? 2 sig fig. Okay. 352. My lowest one is 2 sig fig. For multiplication and division, you go with the lowest number of significant figure, which is 2. So, what I have to do, I have to round my final answer to reflect that. My answer is 45.01183. I have to round this to reflect that, okay? So I need to forget about the decimal places. And this is 0, so I will round down. It would be 45. My final answer should be 45. 2 sig fig. So far, so good? Okay, so multiplication and division, you go with the lowest number of significant figure, and then you round the final answer to reflect that. Now, the next one we're gonna go, the next one is a little bit tougher. So multiplication and division is the easier part. The tougher part is subtraction and addition. Subtraction and addition. Now, I'm actually gonna you don't just go with the lowest number of significant figure. It's a little bit more complicated. I want to show you with a practice problem. 5.74 plus 0.823 plus 2.651. Okay? If you put in your calculator is going to give you, you tell me, 9.214. Now the question is, how do I report this? Now here's the way I want you to do it. There are two ways. There's a way that is not good, but I'm going to show you anyway, and there's a way that is good, and I want you to do it that way. So here's the way that is not good, but I'll show you anyway. You can go based on the lowest number of decimal. How many decimal is this? 2, 3, 3. So my final answer should only have 2 decimal places. Here's why I don't like that. What happens if your numbers don't have decimal places? Then you're screwed, right? So here's the way I want you to do it. I want you to line them up on top of each other. 5.74, 0.823, 2.651. Line them up, okay? And the answer is 9.214. Now, I want you to draw a line where things are not significant anymore. I want you to draw a line where things is not significant anymore. So after the 4, there is nothing that is significant. So this guy is bringing you down. After the 4, nothing is significant. So I'm going to draw a line where things are not significant anymore. Now, everything behind this line is going to determine my number of significant figures. So based on this, I have 3 sig fig. Everything behind this line is going to determine number of significant figures. So I have 3 significant figures, 9.214. So this is 4. 1 to 4, you always round down. So my answer is 9.21. 9.21 because I'm supposed to have 3 sig fig. Again, if this was 9.216, I will round up to 9.22. But 4, you round down. Okay, so far so good. All right, now let's do a couple more practice problems. Now, bunch of operations together. So for addition and subtraction, I want you to line them up, draw the line where things are not significant anymore, and everything behind that line, look at it, that will determine your significant figure. So now let's get really fancy and do an operation that has a bunch of things together. Okay, here's what I'm going to do. 3.489 times 5.67 minus 2.3. Okay? Now, in order of operation, which one do I need to do first? I need to do the parentheses first, right? The parentheses, I have subtraction. So what I'm going to do, I'm going to line them up on top of each other. I have subtraction. I'm going to line them up. You following me so far? I'm going to line them up on top of each other. So far, so good. Then I'm going to draw a line where things are not significant anymore. Where is that line would be? Where would that line be? That line would be, is anything significant after 3? Is not. The line would be here. Now, behind this line is going to determine my significant figure. Behind this line, I have 2 numbers. So I have 2 sig fig. You follow me so far? So I'm supposed to have 2 sig fig for the parentheses. Are you going to round it to 3.84? No. Pay attention. If you have bunch of operations going on, you cannot round at every step. If you keep rounding early on, your final answer is going to be really, really off, right? If you keep rounding every step from the very beginning, your final answer is going to be really, really off. So what we do not round until the very end. We do not round until the very end. But I know in my mind that this one over here has 2 sig fig. You following me? Beautiful. Okay. So now, what I'm going to do, I want to multiply 3.489 times 3.37. If you do that, your calculator is going to give you 11.75793. Okay? Now, pay attention. Give me a couple more minutes of your time. Now is a multiplication. Multiplication and division is easy. I go with the lowest number of significant figure. Addition and subtraction, I have to do that. Okay, how many sig fig is this? This is 4 sig fig. Now remember what we talked about. This number was supposed to have how many sig fig? 2, but we didn't round it. We're going to keep all the numbers. So this is in reality should have 2 sig fig. So my final answer should have 2 sig fig. Beautiful. Is 11.75793. So it's 7. To round it, I would have to round it up. I will round it up to 12. Okay. Very nice job. Very nice job. All right. We're good. Now, what I'm going to give you, I want to give you take-home problems. I want to give you 3 problems to do at home. And then next time, the minute you walk in, we don't walk in, the minute you turn on the video, those are the take-home problems that I want to go over. I want to give you the take-home problem, and then there's one more quick thing I want to go over to make sure that you guys are getting this down. Here's the take-home problem. You ready? Number 1. 3.2215 times 1.67 plus 2.3. Number 2, 1.0080 times 12010. Number 3, 1780 plus 3500 plus 21.77. Now, what do I want me to do? What do I want you to do? What I want you to do, I want you to write down the final answer in a correct number of significant figures. Write down the final answer in a correct number of significant figures. These are not easy problems. They're not. They're not easy problems at all. But I think you got this. You want to do hard problems at home, so you're ready for the exam. So when you turn on my video next time, this is the first thing we're going to do. Now, you guys copy it down? Beautiful. There's one more thing I want to go over before you, and again, I want to go over the next thing because I want to make sure that we're on the same page. I don't want to assume that you remember things from back in the days. Let's do this. Now, when you're rounding the final answer, first of all, when do you round? You round when you want your final answer to match the number of significant figure, okay? When you have number 1 to 4, you always round down. When you have 6 to 9, you round up, okay? So for example, if I have 12.4 and 12.7 to round to 2 sig fig, this would be 13, and this would be just 12 to round to 2 sig fig, okay? Now, what happens if you have 5? 1 to 4, you round down, so 12.4 would just be 12. If I want only 2 sig fig, right? And 12.7 would be 13. You round up. Now what happens if I have 5? So if you have 5, it's a little bit more complicated. And you can, some people say, just if you have 5, round it up every time. But if we have 5 and we round up every time, then we're rounding more up than we're rounding down. So here's the official rule for 5. Not many people actually follow it, and if you don't do it in Chem 38, that's okay. But I wanted you to know what is the official rule for 5. Let's say I have 75.45. and I want to round it to 3 sig fig. And then I have 75.55. I want to round to only 3 sig fig. Here's the official rule. So I have my last one is 5, and I want to round to 3 sig fig. You have to look at the number before. The number before 5, so you look at the number before 5. If the number before 5 is even, you round down. If the number before 5 is odd, you round up. So this one would be 75.4. This one would be 75.6. So you look at the number before 5. If it's even, you round down. If it's odd, you round up. Okay, again, this is a rule that a lot of people don't follow, and if you don't follow, it's okay too. But I wanted to make sure that you really understand that. Now, let's do one more practice problem with rounding with 5. Again, 1 to 4, you just round down. You got that down. And then 6 to 9, you round it up. Now, what happens when we have 5? So here is, let's do this one. Let's do 73.5 and 72.05. And the first one, I wanted to round to 2 sig fig. And this one I want to round to 3 sig fig. You ready? Okay. So what are you going to do? So I have 5 and I want to round them. The first one to 2 sig fig, the next one to 3 sig fig. You look at the number before 5. The number before 5, what is that? Is that odd or is that even? That number is odd. So if you have a number that is odd, I have to round up. I have to round up to 70 to 74. Okay? So I have 73.5, I only want 2 sig fig, I would have to round up. I have 5, but this is odd. Now I have 72.05, okay? Now what is this number? This number is even, okay? If I have an even number, what do? I just do 72.0. Now, if this number was odd, it would be 72.1. Sounds good? So if this was, so again, when you have 5, 1 to 4, you always round down. 6 to 9, you round up. Now, 5, usually everyone just keeps rounding up, but to be really correct, you have to look at the number before 5. If that number is odd, you round up. If that number is even, you round down. So if this number was, for example, 1, I would be 72.2. But this number is even, so I have to round it down. Sounds good? Okay. Now, don't forget, what you are going to do next time, do the take-home problem. Do the take-home problem. The minute that you open the video, next video, we're going to do the take-home problem and then go from there. Hey, nice job. Survived the first lecture.